You and I both know that when we're taking off and climbing out in an airplane, we have to hold lots of right rudder. Here's a good example of a guy holding lots of right rudder when he's taking off here. Now the question is, why do you have to hold right rudder when you're climbing out and taking off? And the FAA wants you to understand that really well. Well, the reason you have to hold right rudder is the airplane has a left turning tendency. And the reason the airplane has a left turning tendency, one of those reasons is P-factor. Now, P-factor has nothing to do with how long you've flown since you've gone to the bathroom. No, that's not what it has to do with. P-factor has to do with the pitch of the prop blades. And when an airplane is in slow flight, like after takeoff or when you're climbing out, the nose of the airplane is pointed way up in the air like so, but the airplane is going forward on an angle about like this. That means the relative wind is coming from the opposite direction. And that means the propeller is not pointed directly into the relative wind. And the right prop blade, which goes down, winds up taking a great big bite out of that relative wind. The left prop blade, which ascends or goes up, takes a much smaller bite out of that relative wind. And that means the airplane wants to turn to the left. And that is called P-factor, or asymmetric propeller loading. And it causes the airplane to yaw to the left when you're at high angles of attack. And they call that P-factor, or asymmetric propeller loading. Now, the left turning tendency of an airplane is caused by, the FAA wants you to know, the propeller blade on the right producing more thrust than the blade on the left. Now, that left turning tendency is sometimes referred to as torque, T-O-R-Q-U-E, and they're going to ask you, when is torque the greatest, at high power or low power? Well, the propeller and the engine horsepower are what makes the airplane want to turn to the left, so at high power, definitely. High airspeed or low airspeed? And the answer is low airspeed, because that's when you have these high angles of attack with the nose pointed up in the air and the right prop blade is taking a bigger bite out of the air. And high angle of attack or low angle of attack, and the answer is high angle of attack. Now, normally, at cruise speed, an airplane does not want to turn to the left. And the reason for that is the manufacturer has built some aerodynamic compensations into the airplane. For instance, there's a little bigger angle of attack built right into the left wing and a little smaller angle of attack built into the right wing. And the tail is canted a little bit to the right. And these aerodynamic compensations counterbalance the left-hand turning tendency of the aircraft. But when the airplane is slow, there's not enough air over the wings and tail to counterbalance that left turning tendency. And also, when you have high power, there's more of a left turning tendency. So torque effect, that's the left turning tendency, is greatest when? Well, it's greatest at low airspeed, high power, and high angles of attack.